The following is a production of the University of Minnesota.
My name is Eric Watkins, and I'm an associate professor in the Department of Horticultural Science, and I lead the turfgrass breeding program. And in the turfgrass breeding program, one of the things we're always trying to do is develop new varieties of grasses that need fewer inputs. So inputs could be water, fertilizer, pesticides, mowing could be considered an input. So the overall goal of our program is to develop these low input grasses, but we also want to develop low input grasses that survive the winter due to our very harsh winters in Minnesota. One of the more promising long-term projects we have here in our turfgrass breeding program is focused on prairie June grass. Prairie June grass is a native grass that can be found throughout the western part of the U.S. You often find it in the Great Plains, growing on shortgrass prairies. You'll find it growing in really hot, dry conditions, so that would indicate it probably has some pretty good tolerances to some of the harsh conditions you might find in a lawn that doesn't receive any inputs. So what we're standing on today is a prairie June grass trial that was planted in 2008, and it has not received any additional inputs since establishment. So we seeded it, got it going with some fertilizer, and now since the spring of 2009, we haven't fertilized, we haven't used any pesticides, we haven't done any extra irrigation. It's only gotten natural rainfall. It gets very little mowing, maybe one time a month or so, or even less. And you can see a lot of the plots look like you might expect. They look, full of weeds. They have bare spots. The grass doesn't look very green. So this is kind of what you would expect from a really low maintenance turf after about 5 years. However, there's also a number of plots in here that show some fairly decent quality considering the conditions they've been growing under. I'm standing next to one here. This is a plot of prairie June grass, and this actually is a variety developed in Europe. So this was developed with germplasm that was collected in Europe. This species, although native to the U.S., is also native to parts of Europe and Asia. It's what we call a circumpolar species. And you can see in this plot, the turf is still pretty dense. This plot has very few weeds, which is pretty amazing considering we haven't applied any herbicides since this was planted in 2008. It's got good color even during a hot stretch of weather we've had during the summer, and this is the case last year in 2012. We had a really, really hot summer, and this June grass did just fine. It has no problems with winter. It's really the ideal low input turf grass. There's a few other examples around here. You can see right here, another plot. Very nice color, good texture, really doing well in this low input environment. For comparison then, we can see, in front of it, what I talked about before. So this plot has a lot of dandelion invasion. There's some other grasses that have got in here, some tall fescue, there's some clover. This plot has not done well. So what happened is this plot established okay, and then over time it wasn't able to perform well as a low input turf. If you look really closely at some of these native plots, so this plot is from native germplasm, not from European germplasm, they also have a problem with mowing quality. So when the mower comes and tries to mow off these leaves, the tips kind of shred off. So you get this kind of frayed leaf tip appearance, and that's going to also degrade from the aesthetics. The European types do not have that negative trait. So you might wonder why we don't just plant the European varieties if they're so spectacular as low input turf. Well, the problem is that these European types do not produce viable or economically viable amounts of seed when grown for seed production. So there's really not a seed supply that consumers can use in their lawn. So it's got everything necessary for a low input turf except for availability of the seed, and that's a big problem. Fortunately, a lot of our research in the last few years has indicated that some of these native types, although their turf quality is certainly not up to the same level as the European germplasm, these native types often have much better seed production at a level that might be economically viable. So in addition to doing work on turfgrass research, we've also done some work on evaluating seed production of some of our native types, of looking at seed production in northern Minnesota, just to try to get a read on the potential of some of our native types. And what we're working on right now is we're collaborating with some industry partners to combine the traits from some of these European types with the native types that we have in our program, with the hopes that we can develop a new variety that would have these really excellent low input turfgrass qualities qualities along with the good seed production traits of our native types. Now this is a long-term project. We've been working on this for about 8 or 9 years, and I would expect it's going to take several more years before we even get close to developing a variety. So it might be, even if things go well, it'll probably be, between 5 and 10 years before a new variety would be widely accessible to the public.